Hello everyone. Today's problem is figure shows a pictorial view of an object by using first angle method of projection. Draw front view, sectional left hand side view along sectional plane AA, top view, and you have to give dimensions. There are four marks for front view. Sorry, 5 marks are for front view, 5 marks for left hand side view, 5 marks for top view, and 1 mark is for dimension. So total marks are 16. So this is the object and this is the x direction in which you have to draw front view. Okay, you have to draw normal front view. So we'll start the front view. So here we'll draw the front view, here left hand side view, and here top view. So first we'll mark the overall dimension of an object. So in a front view, which two dimensions are visible? Its height and its length. So 16, right? The 16 height, 16 plus this height up to the center, that hole is 60, and above that you have to add this distance, and this distance is equal to the radius of this outer circle. The outer circle radius is 20. So 20. So total height of this object is 96. So we'll mark here the 96 height. Okay, and total width is 68. So we'll mark that 68 here. Okay, this is 96 and this is 68. Okay, then we'll mark the overall dimension in a top view. So this is 68 by 68. So length and width is visible in a top view. So 68 and 68. So 68 length we have already in a front view, so we'll project it. Okay, then 68 this side, okay. Then in a left hand side view, 68 and its total height is visible. So total height is 96, which we have already in a front view, so we'll project it. Right, so this is 96 again, and 68 will project from the top view. So to project it, the intersection point of xy line and x1 y1 line, from that point you have to draw a line inclined at 45 degree. You want to project this dimension, so we'll project this point up to this in 45 degree inclined line on this also, and we'll draw vertical line through these points. So this so here you'll get this 68 distance. Clear? So these are the overall dimensions of an our front view, top view, and left hand side view. Now we'll start the front view. So in a front direction, which surfaces are visible? This surface is visible, then this surface is visible, and this surface is visible. So let's draw it. So first we'll draw this 60, this rectangular surface 68 by 16. So we have 68 here, and right, and this is 16. This is the first surface. Okay, then see from front side, this hole, right, this hole is not visible, so you have to draw dotted line for it, or a dash line for it, or it is also called as a hidden line. So from this direction it is not visible, so first we'll mark its center. Now from this side, its center is at a 26, and this center is also at a 26 from this side. So we'll mark it. So from here 20, at a 26 mm. We'll first draw the center line. From this side also 26 mm, right? Then from this center line, this radius is 8 mm. So from this center line at 8 mm, we draw that hidden line. From here also at 8 mm, we'll draw that hidden line, right? So these are the hidden line, and this is center line. First we'll mark the center line, and then from the center line, its radius is 8 mm. So at the 8 mm distance, we draw this hidden line. Okay, now we'll draw this surface. Okay, now from this surface, the center of this two circle or this hole is at a 60 mm. So from here you can mark that 60 mm distance. So from this line you have to mark that 60 mm distance, right? This surface is at the center of this 60 mm, right? The center is at a middle of 60 mm distance. So at the middle we'll mark that, we'll draw the center line. Okay, this distance, okay, this distance is 60. Okay, this distance is 60, right? And this is 16. Okay, then we'll draw that surface. Okay, so first we'll draw this outer circle whose diameter is 40. Okay, then this inner circle is diameter is 520. Okay, so we'll get this surface. Then we'll draw these edges. Now these edges are tangential to this outer circle, so we'll draw from this point tangent to this outer circle like this.